So Pythagorean theorem is not something that is new to you. You did that in middle school math. If you remember, Pythagorean theorem is a squared plus b squared is equal to c squared. And when do you use Pythagorean theorem? Pythagorean theorem is when you're given two sides of a right triangle, and you're being asked for, or you want, the third side. Now, the reason I point that out is because we're going to run into, in this unit, a lot of situations where you're given different information and you want different, so you want to find a side or you want to find an angle. And it depends on what you're given as to what you end up using, whether you use trigonometry that we're going to get to later or special right triangles. There are different things that you can use to solve right triangles depending on what you need to find and what you have. So if we want to check and make sure that these are the sides of a right triangle, then you're going to test the Pythagorean theorem. So we're just going to test a squared plus b squared is equal to c squared. Now be careful, it's not the first one and plus the second one equals the third one, okay? Now this is not, we're not testing to see if it is a triangle like we did before. We are actually checking to see if it is a right triangle. And if it's a right triangle, it's going to work with Pythagorean theorem. So we would do C has to be our longest side. It's not the order that they're written in, it's which one is the longest. So we have a squared plus b squared is equal to c squared. And I'm asking, is that true? That's what we have to ask ourselves to determine whether these are the sides of a right triangle. So if you type in 7 squared plus 14 squared on your calculator, you get 245. So 245, is that equal to 225? No, so then these do not represent the sides of a right triangle. So then we test this. 20 is our C, that's our longest side. So we test 8 squared plus 18 squared is equal to 20 squared. If you type that in your calculator, 8 squared plus 18 squared does not equal 20 squared. And so these are not the sides of a right triangle. Then you could do the same thing. You've got your sides. You do 1.6 squared plus 6.3 squared. And you ask yourself, is that equal to 6.5 squared? And in this case, yes, it is true. So you always go in, find your longest side. That's the side you use for your hypotenuse. And then you check and see, is it a right triangle? Not is it a triangle, but is it a right triangle? When then you test a squared plus b squared equals c squared. Now, there are what we call Pythagorean triples. Pythagorean triples are very, very useful ways of getting out of having to do the Pythagorean theorem. So doing a little bit of memory work keeps you out of doing a whole lot of Pythagorean theorem work. These are really good for college board tests, for SAT, ACT. It just makes the math go a whole lot faster because you don't have to do so much work. So you just need to memorize them so that you recognize them when they come up. So there are the four most common families of Pythagorean triples are this. We've got a 3, 4, 5 triangle, a 5, 12, 13 triangle, an 8, 15, 17 triangle, and a 7, 24, 25 triangle. So now what it means by families is you could also have multiples of that. So you could have a 6, 8, 10 because everything's been multiplied by 2, or a 9, 12, 15 because everything's been, the 3, 4, 5 has been multiplied by 3. So you can have all of those in ratio with each other also. That's what it means by families. So your basic ones, though, are 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. It is worth your time to commit those to memory. Because just to start off the bat, if you look at number 1, now, let me back up, point out. This is where the hypotenuse has to be. If you are ever given a triangle where you have, say, 3 and 5, then the hypotenuse cannot be 4 because it has to be the longest side, and so you cannot have 4. So the 5, the 13, the 17, the 25, those have to be on the hypotenuse in order for these triples to work. So location is important. But if you look at number 1, you notice that the 13 is on the hypotenuse, the 5 is on the leg. Well, then this is automatically a 5, 12, 13 triangle. You're done. You don't have to do anything. Now, if you don't have these memorized, no problem. You're just going to have to do the work, Pythagorean theorem. So x squared plus 5 squared is equal to 13 squared. Remember, you do exponents first. Subtract 25 from both sides. And then take the square root of both sides. And the square root of 144 is 12. So you do get 12. Now, notice I did ask you to leave your answers in simplified root form. The only time you don't is if I say the words approximately or about how many or round to the nearest. That's when you have permission to hit your square root key on your calculator. Otherwise, you leave your answers in simplified roots. So let's look at number 2. So I always look for a triple first, but obviously 10 doesn't have a triple because it could be a triple. It could be from 3, 4, 5, but that'd be 5 times 2, and the other side doesn't work. So it's not a triple. And so we can go in and do Pythagorean Theorem. X squared plus 5 squared is equal to 10 squared. So subtract 25 from both sides. 100 minus 25, you get 75. And when we take the square root of both sides, this is going back to what we did the other day with simplifying radicals. So if you simplify radicals, I'm going to do 3 and 25. And then I notice that 25 is my pair. So I've got my pair that's 25. That comes out. And my radical, my leftovers stay in. So my reduced radical is 5 root 3. So x is 5 root 3. Then with number 3, I've got x squared plus 5 squared is equal to 5 root 2 squared. This is important right here, putting this in parentheses and squaring it. If you just write 5 root 2 squared, now you may do it right, but it's written wrong. That only means that you're squaring the root 2 and not the 5. So we have x squared plus 25 is equal to, if you square the 5, you get 25. If you square the root 2, you get 2. And when you multiply those together, you get 50. Subtract 25 from both sides, and you get x squared is equal to 25, or x is equal to 5. Now, one of the things that's important about these 3, is that they all have shortcuts. Once you recognize them, they all have shortcuts. Now, 2 and 3, we haven't done those shortcuts yet. When we get to special right triangles, you'll understand more about that and how to look for those kinds of triangles. So there are going to be ways around doing Pythagorean Theorem, and that's what we're going to learn in the rest of this unit. When you get to 4, the biggest thing about 4 that you need to be careful of is the location of the hypotenuse. The x is the hypotenuse. It's not always right or left. Sometimes the triangles are turned around. The other thing to be careful of is that 2 root 3. So if we do 2 root 3 squared plus 2 squared equals to x squared. Remember, 2 root 3, you got to square the 2 and square the root 3. 2 squared is 4. Root 3 squared is 3, so that's 12. Plus 4. So 16 is equal to x squared, so x is 4. Okay, now 5, so say for instance later on we get to a problem and I want to know the area of this triangle. The problem is I don't know the height of the triangle, but I do know how to find it because I have this little right triangle right there inside it because that altitude x. Well, if you remember, when you have an altitude that drops down from an isosceles triangle, it bisects the base. So we know that that side is 6. Now, if you're familiar with your triples, then you know that 10 would be 5 times 2. 6 would be 3 times 2. So there's a 3 and a 5 of the 3, 4, 5 triangle. They're in the right place, which means x would have to be 4 times 2 or 8. So you can instantly know that x is 8 with just a little bit of memory work. But again, if you don't remember that, if you don't see that straight off, no problem. X squared plus 6 squared is equal to 10 squared. You subtract 36 from both sides, you get x squared is equal to 64, or x is equal to 8. So you can end up in the same place. You just have to do a little bit more work. Now on number 6, I promise that you're going to see it again. This is a great question. So I want you to kind of think about this. So everything that we know, and obviously we're in the Pythagorean Theorem section, so obviously you're going to need Pythagorean Theorem, but this is a trapezoid. So the question is, how can you create a right triangle out of this trapezoid? And again, this is the same thing that we'll run into later. When I need the area of a trapezoid, I'm going to need the height. So kind of think back. You remember those puzzles, if you've ever seen them come up, where you have toothpicks that maybe look like this, and you're supposed to pick up one and move it so that you can make a letter or make a number or make something else. Well, so think of that, this problem kind of like that. We're not going to add any toothpicks. We've got these 4 toothpicks right here, and I want to move those toothpicks so that I can make a triangle. And it doesn't have to be just a single triangle. It can have overhangs. I just need a triangle in the picture that I can use to find the height, because I have everything except for the one piece. So here's what happens. I can take this side right here, and what happens if I slide it over? If I slide it over 7, right? It slides over 7 and it slides over 7. Then I have 15 left. Now, see this little right triangle right here? That's what I need. So I slid that toothpick over. I didn't add a new one. I slid that toothpick over. That's X. Now, again, notice that 15 and that 17. That should be ringing some bells, that Pythagorean triple. But, again, if you don't recognize that, I know that the answer is 8, because that's an 8, 15, 17 triple. But if you don't recognize that, it's okay. You would just do Pythagorean theorem. X squared plus 15 squared is equal to 17 squared. And 289 minus 225 is 64. And so that means that X is 8, which we already had from the triple. Okay, so that is very important that you recognize you can manipulate these things and put things in so that they're helpful to you. So if we look at number 7, ask for the perimeter. The first thing some of you are going to do is be like, well, I'm going to skip that question. But let's look at this. AB. Well, if I want to know how long AB is, I'm going to use what I know about Pythagorean theorem. So I'm going to create that right triangle because I can count that vertical and horizontal. Well, this is 5 vertically, and it is 12 horizontally. Well, that's 5 and 12. If you know your triples, then you'll know that AB is 13. Now, again, you could do 5 squared plus 12 squared, get 169, and find out that it's 13. But why do all that work if you don't have to? But if you forget the triples, you can always resort back to that. Then let's look for BC. Let me draw in the right triangle that gets me BC as the hypotenuse. I recognize that this is 3 and this is 4. Well, if the vertical is 3 and the horizontal is 4, that means that the diagonal has to be 5. So that's pretty good. 2 for 2, I've got triples. Now let's check this one, AC. You draw in one of the right triangles, and notice this is 16 and this is 2. Well, that's not a triple. That's not going to do me any good. So I have 2 squared plus 16 squared is equal to C squared. And so if you do the math, because I said you can round your answer to 3 decimal places, so 2 squared plus 16 squared, take the square root of that, you get that C is 16.125. That's how long AC is. Right? That's how long AC is. But I asked for the perimeter of the triangle. So if I take that 16 for AC and add the 13 and the 5, so add in another 18, I get that the perimeter of the triangle is 34.125. You can see this would be a whole lot more work if you had to do Pythagorean theorem if you didn't recognize the triples. Now, what I see is 3 word problems. 3 word problems with no pictures in geometry, and that just doesn't work. So the first thing that you want to do is you always want to draw a picture. So I've got a building. I've got a ladder leaning against a building, so I'm going to draw the picture kind of a little bit so I can see it. I've got a ladder leaning against the building, so that's my ladder, and it is 15 feet long. It is placed 5 feet from the bottom of the building. Here's the bottom of the building. Here's the bottom of the ladder. So that is 5 feet long. how high up the ladder will, or how high up will the building, how high up the building will the ladder reach? Now we know it has to be less than 15 because you're not going to set the ladder up straight against the building. That doesn't make any sense, and it would reach 15 feet if the ladder was flat against the wall. So we've got x squared plus 5 squared is equal to 15 squared. Now the first it says find the exact answer, and then it says find it to the nearest foot. So we've got 225 minus 25, so you get x squared is equal to the square root of 200. When we simplify that, we get that x is equal to 10 root 2. Almost wrote it backwards. Buddies go out, pairs go out, radicals stay in. Okay, so then we've got x is 10 root 2. Then the answer to that to the nearest foot, so you would type in the square root of 200 or 10 root 2, either one, and you get that. That is approximately, the exact answer is 10 root 2. The approximate answer is 14 feet because it says to the nearest foot. So it'd be 14 feet. Because I decided that the rest of the decimals didn't matter. 9 says, how many feet of fencing are needed to enclose a rectangular garden? So I have a garden that has a 50-foot side. It doesn't matter which one you label 50, and a 60-foot long diagonal. Okay, so I need this length. And that's just part of the problem because I actually want the distance all the way around, which is perimeter. So I use this little right triangle right here to find what I need. X squared plus 50 squared is equal to 60 squared. So I have 3,600 minus 2,500 is 1,100. And then it says to about how many feet. So the square root of 1,100 is 33.16. So it's about 33 feet, 33.2 feet. Since I didn't tell you where to round, it doesn't matter. But we'll just, the rest of the numbers are whole, your significant digits. The rest of your numbers are whole numbers. So we'll go with whole numbers too. And so then perimeter would be, this side would be 50, this side would be 33 and 33. So 50 plus 50 is 100, plus 33 and 33 is 166 feet of fencing. That's what you need to go all the way around. Then the last one, a square park has a diagonal walkway from one corner to the other. So we draw a square with a diagonal walkway. And the walkway is 38 yards long. So what's the approximate length of each side of the park? So we know that each of those is x. So I have x squared plus x squared is equal to 38 squared. Now I know I only have one side length instead of two, but I do know that two of the side lengths are the same. And that's why we're able to do this. So 1x squared plus 1x squared is 2x squared. And 38 squared is 1444. I need to solve for x squared, so I'm going to divide both sides by 2. I get x squared is equal to 722. And then I need to take the square root of that. And I get 26.87. It says the approximate length, so x is equal to approximately 27 feet. To match up with the way that the other numbers are, we'll just round to the nearest whole number. So Pythagorean theorem is a squared plus b squared is equal to c squared, and we use it when we have two sides and we need the third side.